we're just going to solve this quadratic. So I've got x squared minus 6x plus 13. Cannot factor that. You're not going to find factors of 13 that add up to negative 6. So honestly, if you wanted to solve this with completing the square, it wouldn't be bad because your b value is negative 6, but I'm going to go ahead and use the quadratic formula. How many answers should this question have? 2. All right, so if we just did quadratic formula, just real quick, I'd have opposite of b, so right, that'd be positive 6 plus or minus square root. And let's see, b squared would be negative 6 squared, 4 times 1 times 13. And then don't forget everybody over 2 times your a value, so 2 times 1. If you simplify, I'm not going to take the square root. If I just simplify what's under the square root, we're going to have 6 squared would be 36 minus 4 times 1 is not going to change it, times 13. So really 4 times 13. And this makes me happy because I got negative 16, which I know is the perfect square in imaginary land. So how would you write down square root of negative 16 if you're going to simplify it? 4i, right? Okay. Now, can anybody raise your hand? Can you tell me? Can I break that down or simplify that any further? Like, what would you write down as your answer? Okay, so what would you write?
3 plus or minus 2i.
Perfect. 3 plus or minus 2i. Now, the plus and minus symbol is a little shorthand way for us to write two answers at one time, but really this is saying 3 plus 2i is an answer and 3 minus 2i is an answer. Now, on this particular question, I was showing you guys some graphs yesterday that you could kind of check the decimals with the irrational roots. You're not going to be able to do that with an imaginary root because you cannot see an imaginary root on the graph. So this is just strictly algebra to solve these today that we're going to work with. So these are called complex numbers, if you remember mentioning this in our last unit. So complex numbers are just in the form of a plus bi. A is the real part and b times i, that's the imaginary part. So complex conjugates are just of this format you just see right here, 3 plus 2i, 3 minus 2i. In a general form, it would be written as a plus bi, and its conjugate would be a minus bi. So if one is an answer, automatically its conjugate is an answer. You can see we got that quadratic formula. We're going to break it down, get that plus and minus. So these are going to come in pairs just like they did when we were working with the irrational roots. So the imaginary root theorem, super similar to yesterday, is going to say if a plus bi is a root, or maybe they say 0 or answer or solution, any of those terms would work. If a plus bi is going to be an answer to your polynomial, or I'll say it like this, is a root of a polynomial, then automatically a minus bi, which is its conjugate, is also going to be a root. All right, then a minus bi is also. All right, now just remember, these come in pairs. So if there's always two of these. If you have an imaginary answer, you really automatically have two imaginary answers anytime you have a polynomial. So they come in pairs. Keep that in mind. Same thing for yesterday, irrational, they come in pairs. Now, forgive me on this. This should say given two roots of a polynomial with real coefficients, find any additional roots, because not all these questions have two answers. Okay, now, just if you've got two parts to it, so if you've got a real part and an imaginary part, I've got 2 plus 9i, automatically, you just switch up the sign in the middle. Its conjugate would be 2 minus 9i. Those are both going to be answers. If one, you have the other automatically. Now, if you just have a plain, just strictly imaginary, don't have any real part to that, just negative 7i, its conjugate still exists. It would be plus 7i. And just as a little shortcut, can anybody tell me, this would not be a linear factor, it would be a quadratic factor. Could you tell me the factor that would go with negative 7i, or like plus or minus 7i? Like, what would it be?
X squared plus 49.
Exactly. So automatically I would know x squared plus 49. It's a little bit more work to write it out for the two part, like I have the 2 plus 9i, 2 minus 9. It's a little more work, but if you just have a single imaginary number and its conjugate, you can just go ahead and write the factor if you want to, or I'll show you how to do it to multiply it out as well. Okay, now the one in the middle, the point I want to make about this says -6 minus 5i. You do not change the negative in front of the 6. It's not the opposite of the number, it is the conjugate of the number, which just switches up that operation symbol in the middle. So this would still be -6, but then its conjugate would be plus 5i. Okay, now I have 4i, so it does have a conjugate, which would be -4i. And just for that one, with just this just by itself, could you tell me it wouldn't be linear, it'd be quadratic. What would be the factor that would have plus or minus 4i? Yes, this one would be x squared plus 16. It has to be plus, because if I set that equal to 0, like here, you'd subtract 16, so you'd have -16 would be what you would take the square root of. Like here, subtract 49. That's what introduces the I. So this would have to be a plus. If you want to write it like this, if not, I'll show you how to write it out if that doesn't make sense. Okay, now on the last one, this is what I want to make a point about. If you get a number, I have -15 here, don't write positive 15. Okay, so just a number by itself, do not write the opposite or what you might think is the conjugate of that number. Don't do that. It's just by itself. So if you're going to write a conjugate, it has to have an I or it has to have a square root of some kind. So this would just have 3 answers. This would be -15, and then the conjugate here would be 7 minus 3i. But if you just get a number, and that could be something like a half, don't write -1/2, because opposites are not conjugates. They do not automatically become an answer to that polynomial. It's only if it has an I or a square root with it. All right, so here's what we did yesterday. And I'm going to have us write standard form, but we're going to start with factored form. So if one of my answers is just 6, how would I translate 6 into a factor of the polynomial? Perfect, x minus 6. Okay, plain number by itself, do not write its opposite, conjugate, whatever. Just a plain number, don't write -6. Okay, now, if -9i is an answer, automatically, because that's got an I with it, its conjugate would be plus 9i, would also be an answer. Okay, could you guys look at these two, and it would be, because there's 2 of them, it would be a quadratic factor. Perfect, x squared plus 81. Okay, now, if you're like, what the heck, where are you getting it? If you were to actually set these up as a linear factor, one for each, you could do x plus 9i times x minus 9i. And you could actually FOIL that out, which you do, if you understand this x squared plus 81, just ignore me for a second. If you FOIL this out, you get x squared minus 9ix. And then because these are conjugates, you turn around and get plus 9ix, so those terms cancel. 9 times -9 gives you -81. I times I gives you I squared. And then this is important for today. Do you guys remember what I squared is equal to? -1. Okay, so just remember that. That's just the definition. Now, in this case here, what I have is x squared minus 81 times -1, which simplifies to x squared plus 81. That's where that's coming from. If you just looked at that 9i, -9i, and you thought to yourself x squared plus 81, you do not need to go through that process if you understand that. If you don't, it's okay. You can FOIL that out and you can get that same factor. All right, to ultimately answer the question, though, I got to keep going with this a little bit. We got to keep doing a FOIL or box, whatever you want to. I don't know why I just wrote that like that. Should have 0 equals this, since these are the zeros. Now, this would be x cubed plus 81x, then minus 6x squared, and then I'm going to grab my calculator real quick, sorry. 6 times 81, 6 is negative times 81 is -486. Now, there's no like terms here to combine, but a lot of times if you multiply out something in this format, you might not be in standard form, which is the case here. I need to trade these 2 terms in the middle places to write this properly in standard form. So my highest power of x comes first. Then I should write the -6x squared, that's next power of x, plus 81x, and then minus 486 is going to stay where it's at. But just make sure your answer's in standard form before you write it down. And occasionally that might not be the case as you multiply it out, so you might have to switch some terms. I didn't change any signs or anything, I just physically moved the terms to the correct location. Is anybody having a question so far? Okay, now we're going to do a couple trickier ones on the back where they have two parts to the imaginary number. Okay, this is super similar to yesterday, and if you like the little box from yesterday, you can use the little box again today, and it will be the same boxes that you don't have to fill in. But if I have a polynomial, we're going to write this in standard form, but I'm going to start with factored form. So I've got 2 plus 5i. So automatically, its conjugate, which would be 2 minus 5i, is also going to have to be an answer to our question here. Now, when you set up these factors, they're a little more complicated because they've got two pieces to them. Just start with x and then just put a minus. I promise it'll work every time. We're going to have 2 plus 5i. You're just going to put parentheses around those two parts to that imaginary number there. And then x minus, and then in parentheses, its conjugate. Doesn't matter the order, which one comes first or second, doesn't matter the order. I would tell you though, before you try to multiply anything, just do a real quick distributive property with that subtraction sign. That'll get rid of the extra parentheses you got in there. So this will be three parts. It'll be x minus 2 minus 5i, and then x minus 2 again, but then plus 5i. Now, to get the polynomial here, we got the answers, so I'm going backwards from the answers to get the polynomial. We would multiply this out. You could do like a triple distributive property here. I was telling you guys yesterday I really like to use a box for these. Excuse me. And I will draw just a 3 by 3 because there's 3 terms in each of those. And I'm just going to do the x minus 2 minus 5i across the top and the x minus 2 plus 5i down the side. It doesn't matter which one goes where. The same boxes will cancel out today as yesterday. So any of the imaginary parts will cancel out when you multiply these together. So it's these 4 boxes that will cancel out. There should be 5 boxes that you can combine like terms with. Now, I'm going to go ahead and write all the terms out for this, but as you guys are working on the homework, if you're like, whoa, I get this, I get that these cancel, just leave those blank and don't even do it. Just save yourself the time. I'm going to write it out for here so people can see, but this will be x squared minus 2x and then minus 5ix. If you've got I and x in the same term, we just write them in alphabetical order. Then we get negative 2x, positive 4, and 10i. And then I'm going to get positive 5ix. Now, this box here and this box here cancel each other out. One's a positive 5ix, one's a minus 5ix. If you understand that, just skip that step. Now here, 5i times negative 2 is negative 10i. This box and this box will always cancel each other out. The one's positive, one's negative, so they just add up to 0. The bottom corner, though, does not cancel. The I will cancel, and it will be a real number, but it still exists here. So 5 times negative 5 is negative 25, and then, here again, I'm going to get I times I, which is I squared. So what I want to remember there, I squared is equal to negative 1. So what I'm going to have here is negative 25 times negative 1. So this little box right here is really just the number 25. Okay, so what I have then is to put together anything that didn't cancel. So it'll be these 4 boxes here, and then this guy here after we simplified it in the bottom right corner. Now, this will confuse people sometimes too. So negative 2 and negative 2, those two x's don't cancel each other out. They're actually negative 2, negative 4 x's. So all simplified here. Here, I'll tell you what, I'm just going to write it over on this side. I'm going to have x squared, negative 2 minus 4x, 4 and 25 is 29. And since they gave me the zeros, I'm just going to set this equal to 0. That would be my polynomial that has 2 plus or minus 5i as the answer. Now, you absolutely do not have to do this, but I just want to show you real quick. If I used, I'm going to come over here in this space, I'm just going to use the quadratic formula on that real quick. If I do that, I'm going to get 4 plus or minus square root, negative 4 squared, 4 times 1 times 29. Everybody over 2 times 1. Now, if I did this correctly, my two answers should be what they told me originally in the problem, right? Because we were working backwards from that. This is 4 plus or minus. Okay, now I'm just going to grab my calculator, and it's going to be negative because I had eyes, but I'm going to do negative 4 squared minus 4 times 1, which I don't really need to do, but I'm going to, times 29. Okay, nice. This is negative 100, which is the perfect square in imaginary land. So I have 4 plus or minus, that would be 10i over 2. Both the 4 and the 10i are divisible by 2, and guess what? This gives me back 2 plus or minus 5i, which is what they gave us originally in the problem. So if you wanted to check, you could do it that way just using the quadratic formula. You don't have to. The actual answer to the question is that quadratic, the x squared minus 4x plus 29. Is anybody having a question? Okay, I'm going to do one more with you real quick. This one is just a little more complicated because it has an imaginary root. It has negative 7 minus 4i. So the conjugate, keep the negative 7 and then change this to plus 4i. And then it also has a nice answer that's an integer, just 3. Don't write negative 3, just the 3. All right, don't write a conjugate for a plain number. So my factor there would be x minus 3. And then again, if you've got complex numbers or if you've got irrational numbers like we did yesterday that have two parts to them, just do x minus and then put it in parentheses. So I'm going to do negative 7 minus 4i and x and then negative 7 plus 4i. Before you try to multiply anything, just distribute that subtraction sign real quick to get rid of that extra set of parentheses. Now for this one, if I do minus a negative, that actually turns into x plus 7, and then negative times a negative here. One of these will be a plus 4i. The other one is going to be x plus 7 minus 4i. Now again, if you get a problem like this, do not multiply like the x minus 3 times one of these nightmares, okay? You just multiply the conjugates together and then all the imaginary parts will cancel out. You can multiply it with the x minus 3 there, but just don't, please, because it's just going to be so much extra work. So we're not going to do extra work because that's annoying. All right, now I'm just going to draw myself a beautiful little box. And I'm going to do x7 and 4i down the side. I'm going to do x7 and negative 4i across the top. Doesn't matter, you could switch that up. We would get the same answer. Now, I am not going to do this on this question at all. I'm just not even going to fill them in. I know those boxes are going to cancel each other out. I should get an x squared minus 7x minus another 7x. Those don't cancel. In the very center, 7 times 7 is 49. Now, the bottom corner here would be negative 16i squared, which is really equal to positive 16, right? Negative 16, I squared is negative 1. So negative 16 times negative 1 will give you positive 16. So these 5 boxes, I'm going to combine my like terms to simplify. Oh no, what did I mess up? That's what I wrote, obviously. I'm just kidding. No, you're right. It should be positive 7x. I just automatically wrote the negative. Nope, 7x. Okay. Did I screw anything else up? I think all the other numbers. Okay, sorry about that, guys. Yeah, those should both be positive. That's my fault. Okay, now, don't forget, we have not used this x minus 3 yet, so I'm going to bring that down. If you put these like terms together here, x squared, right? Negative, or positive 7, I just said that. 7 and 7, this will be 14x. That's positive in the middle. 49 and 16, oh my, if we add those together, I think that's 65. Yes, okay. Now, you can draw a box for this if you want to. I usually don't. I just do a little double distributive property in this case, but if you want to, you could draw yourself a 2 by 3 box to multiply this out if you would like. I'm just going to go ahead and do a triple distributive property. So x times all 3 of those terms is just going to put a power of x into each. So it would be x cubed plus 14x squared and then plus 65x. And then what I do, I'm going to multiply everything else in that set of 3 by negative 3. I just line up the like terms to help myself add it vertically. So negative 3 times x squared, I just write it under the other x squared term, which would make it negative 3x squared under the 14x squared. Negative 3 times 14x is going to be negative 42x. And then I don't have another plain number, so I'm just going to put this on the end. But if I do negative 3 times 65, we're going to get 195. That'll be negative. There's only one term with an x cubed, so nothing to combine that with. 14x squareds minus 3x squareds is 11x squareds. Let's see, 65 minus 42 is 23x's, and then there's nothing to combine that negative 195 with. So then this polynomial has zeros of 3, and then plus or minus negative 7, or sorry, negative 7 plus or minus 4i is what I meant to say there. Is anybody having a question?